Well, today, you guys, we're talking about banking formulas. But before we start this, our goal is to talk about the difference between a linear function, which would be a straight line, and an exponential function, which would be a curved line. So linear functions, exponential. Okay, so we started the problem with banking formula. Okay, so Sanjay's family deposited $20,000. That's our principal. Okay, that's our principal. That's how much you start with. In an interest-bearing account for his college fund. Sanjay's account earns simple interest each year. Okay. Chikonde's family deposits $20,000 in an interest-bearing account for her college fund, compounded interest. Okay, you get simple interest and compounded interest. So here's how it works. Sanjay's getting the bad deal. So Sanjay gets $800 every year. If you look at the two columns, Chikonde's gets bigger and bigger and bigger because the bank takes the interest that she made and she makes interest on the interest, which is the way it should be, okay? This is a really bad deal, simple interest, okay? So when you make interest on interest, it becomes an exponential equation. So we have two different formulas. One is a banking formula, simple interest. Simple interest here, A from round is equal to P plus PRT. R is in terms of rate, it's percentage rate. In this case, it's 4%. If it's compounded interest, it's exponential. That's why the T's up here, where the amount is equal to P times 1 plus R to the T power, okay? So we took, we're going to use these, we're going to use these on the next page. So then we took and graphed our line, okay? We took all these points, we graphed them, we got a straight line. Because it is linear. You're only getting $800 a month, right? And I showed a linear equation for this particular graph. Then we took these points and we graphed a line. It curves up slightly because it's growing a little bit faster. It's exponential, and that's why the equation has an exponent, okay? Exponential grows faster, okay? So then, linear, exponential. So then we turn the page and I give the equations again. Okay, if it is simple interest, it's P plus P times PRT, and if it's compounded, it's A equals P times 1 plus R to the T power. So we did it. C of 5, they want the compounded interest, and so we plugged 5 into this equation, okay? 5 into this equation, then we plugged 5 into this equation, so I did both. So here's 5 into compounded, compounded interest. So I took 2,000, which is my P, 1, always the number 1, plus 0.04, because it's 4%, 0.04, 4%, to the 5th power. We used our calculator and we get 24,333.6. I'll share that on the calculator. So it's like this, okay? There it is, 20,000. I'll do it again, 20,000. And I go parentheses 1 plus 0.04 parentheses. And then to the power is that button right there. To the power of 5, and I get that answer, okay? 24,333. And then I did the simple interest, which was I just took my 20,000 plus another 20,000 times my interest rate, 0.04, times my 5 for 5 years, and I didn't get as much money, okay? So the moral of the story is this: don't put your money, if it's simple interest, always do it in compounded interest, okay? Always compounded interest, okay? So these are the formulas you need to know. These two formulas, I'll highlight them. Make sure these are in your notes for our test. Okay, simple interest, compounded interest. Okay, and that's all I have. You guys have a homework assignment, and I'll talk to you about it later tomorrow.